Is your editing system feeling a little sluggish? It might be time for an upgrade. As camera tech progresses, files are getting bigger, demanding more from your video editing computer. The occasional hardware upgrade is essential if you want to continue working with the highest quality video files. If you need help choosing the right configuration for your new editing computer, you're in the right place. In this video, we'll walk through the steps of post-production and discuss which component supports each different task. We'll start with editing and work through audio tasks, visual effects, color work, and exporting. By the end, you'll be able to confidently choose the right computer for your next video editing project. Let's get started. Chris here from Videomaker. There are timecodes below if you want to know what we're covering or want to jump to any place in this video. Do you want to edit faster? If so, we have a list of the top 10 keyboard shortcuts you need to know. To get it, click on this card or the link in the description. The first stop on our post-production tour is editing. Editing is the process of piecing together your footage to create a story. You'll need to complete this step before moving on to any other steps we'll discuss in this video. Editing is all about arranging video clips on a timeline and playing them back so the GPU, or graphics processing unit, is a critical component in this phase of post-production. The CPU, also known as the central processing unit, and GPU work together to support the video editing process. The CPU executes instructions from your computer's programs and processes data, while the GPU is responsible for processing data related to visual output. They can execute instructions doing computations for video encode or decode, as well as visual effects. Pairing a high-end CPU with a high-performance GPU will allow for real-time playback, even when editing RAW, 4K, and other demanding file types. You'll notice that some options offer more or less RAM and VRAM. But what is that? RAM stands for Random Access Memory, and VRAM stands for Video Random Access Memory. While RAM stores cached data for your CPU, VRAM is memory specifically dedicated to graphics processing. Having RAM means your computer can more efficiently multitask. Likewise, more VRAM means your computer can process more video data. This lets you run a larger number of more complex video tasks before your computer starts to bog down. As you shop for a CPU for your editing computer, you'll need to compare a number of different factors. For instance, look for CPUs with a high number of cores. Having more cores spreads out the work so that your computer can multitask more efficiently. Each core can perform a separate process, meaning multiple processes can be executed simultaneously. Therefore, using a CPU with more cores is especially helpful if you need to run multiple applications at once or if your project has a large number of separate tracks. Before choosing a GPU, you'll also want to consider the number and types of cores it offers. GPU cores don't work exactly the same way as CPU cores, but they still help spread out the workload. GPUs are actually made up of thousands of cores that each handle a tiny piece of processing load. The more cores, the more processes that can be performed at once. This is what allows the GPU to process the amount of data needed for high-resolution video formats. Because technology moves so fast, it's best to get a faster, more powerful CPU and GPU than you think you'll need. While the upfront cost might be higher, it will prevent you from having to upgrade again in the near future. That will save you money in the long run. In any case, when choosing either a CPU or GPU, make sure to check which options are compatible with your video editing software. It can also be helpful to look at the benchmark scores to better understand the impact different specs have on performance. After editing comes audio post-production. This includes tasks like syncing audio and editing location audio, cleaning up clips, and adding effects. This is also time to add music and sound effects to your production. To perform all these audio tasks efficiently, you'll be primarily relying on your CPU. As we mentioned earlier, this bit of technology excludes instructions from your computer's programs and processing data, including audio data. Along with the number of cores, you'll also want to look at the clock rate. Measured in gigahertz, the clock rate tells us how many instruction cycles can be executed per second. In other words, it gives us an idea of how fast the computer will be. However, CPUs can't execute more than one instruction per clock cycle, so it's also important to look at the number of instructions per clock. This will give you a more complete picture when comparing the relative speeds of different processors. But why does this matter? We know a higher number of cores means the processor can handle more tasks at one time. But why do we also need a fast clock rate? The answer has to do with the way audio effects are handled by your computer. The CPU can work on several different tracks across several cores, but the effects used on each audio track needs to be processed in a single continuous effects chain. The clock rate affects how fast each of these effects can be processed. If it's too slow, the effects won't render correctly in time, giving you errors in your audio playback. That's why you need a CPU with a faster clock rate when working on audio. Let's move on to visual effects, color correction, and color grading. Visual effects, including any special effects and compositing, as well as motion graphics. Color correction ensures balanced colors and a clear, readable image, while color grading uses color to give your footage a more specific mood or tone. As you might have guessed, a more powerful GPU will make these tasks more efficient. Some editing software relies on the GPU more than others. But in general, a high-performance GPU will allow your video editing computer to render certain effects faster. With GPU acceleration, the GPU takes over the decoding process from the CPU, so the clips with effects like blur and sharpen can be played back in real time without rendering. Transitions like dissolves, dip to black, and wipes will also play back in real time. At the same time, the GPU takes some of the load of the CPU, freeing the CPU up to work on other tasks and boost overall performance. Higher resolution monitors, multiple high resolution monitors, and a higher bit depth will use more GPU memory to store and display these images. If you work with high resolution, high bit depth images, like with HDR, you'll want a GPU with more VRAM. Likewise, color correction and grading effects can also benefit from GPU acceleration. This means you can make adjustments to a clip's color grade and see the results immediately. By skipping over the rendering step, you can speed up your workflow and stay focused on the creative aspects of your work. After you edit your video, fine-tune the audio, add your visual effects, and perfect your color grade, you can finally export the finished video to share with your audience. Exporting is the process of encoding your editing timeline into a video file. Your computer needs to be able to apply your effects and create a playable file without hiccups, capturing the finished product to your storage drive. This requires a powerful machine built with both a powerful CPU and a high-performance GPU. When choosing components for your editing system, make sure to choose a CPU and GPU that supports hardware accelerating encoding and decoding. This will significantly speed up your workflow, especially if you need to export multiple iterations of your project. Now let's take a look at a couple of example system configurations, the Dell 3660 and the Dell 7770. Let's start with the Dell 3660. This desktop workstation offers NVIDIA RTX graphics along with 12th gen Intel Core processing running up to 4.9 GHz with up to 12 cores. This means this system supports smooth playback of high-resolution video during editing and has the clock rate needed for audio post-production. It also supports hardware acceleration for visual effects, color work, and rendering. The Dell 7770 is a mobile workstation that offers Intel CPUs up to Intel Core i9 and NVIDIA GPUs up to NVIDIA RTX A5500. Despite its portable form factor, this high-powerful editing computer supports both video and audio editing with processors up to 16 cores and clock rates of up to 5 GHz. Visual effects and color work benefit from GPU acceleration, and a powerful CPU and GPU pair means fast export times for your video projects. By now, you should have a better idea of which components support each different step. The CPU and GPU both power important tasks in the post-production workflow, so it's worth investing in a system with high-performance hardware. Remember, if you'd like to get our list of the top 10 keyboard shortcuts you need to know, click on this card or the link in the description. If you've made it this far, consider subscribing and liking this video. In the next video, we'll cover all you need to know about monitors for video editing.